Hey everyone, today I wanted to make a video talking about machine learning, artificial intelligence, in perfect information games, imperfect information games, and pattern recognition, and just kind of discuss what I thought machine learning and artificial intelligence was like before I started getting into it and learning it, and how it actually is in real life, because there are some similarities and some differences. So first things first, the simplest example of AI that I've worked with is Tic-Tac-Toe. It's a perfect information game where you can know where all of the pieces are at any given time. And yeah, the objective is obviously to make 3 in a row. And there's roughly 9,000 possible combinations of where the pieces can be located. And it takes an AI that I myself have sort of, I followed someone's model and experimented with their code, and it takes about half an hour on my PC to play perfectly. So if you play it after 15 minutes, you will find that you can dominate it quite easily. There'll be some situations where it doesn't have enough experience and it hasn't learned what the best move is yet, and that still requires, so even there's 9,000 possible games, unique positions, it will still need to play, say, 90,000 games to learn the best move in any position. So yeah, it's kind of weird because if the AI has played 45,000 games and it still hasn't learned that 2 in a row is a good thing if it's itself, or it needs to block 3 in a row for the opponent, that seems really like fake and false and not how a human would approach the problem. Because like as soon as you tell a human that the goal is to make 3 in a row, the human will try and make it will put one piece down, then it will try and make 2 in a row, and then your opponent will start blocking you, and yeah, so I think the crosses are next to play, and it would block here, and it would try and make a line here, for example. So it's kind of interesting that Connect 4 are a very similar game. They kind of depend on these exhaustive Monte Carlo simulations, Monte Carlo tree search, which is basically trial and error. And obviously this has a massive limitation in a game like Connect 4, where the number of unique game states is about 3.5 trillion. So what I did with the AI for that some guy I made for Tic-Tac-Toe, I converted it to play Connect 4, and it does learn to play Connect 4 like in theory it could learn every possible position, but it would take my computer such a long time to learn every position that it's just not feasible. But what you could do is, because you could have the AI learn in real time. So like if I just gave it this position, which is a game in progress, and then start studying from this position onwards, it could probably find the next best move pretty quickly in like a few minutes, or maybe less, I'm not really sure, but yeah, so red is actually next to play, and it would go here. We'd obviously go here, but yeah. So, and yeah, as I said, like making 2 in a row, like simultaneously. So if say, so when blue had 2 pieces here and a piece here, putting this piece in was obviously a good move because it gives 3 in a row and it also gives 2 in a row. So humans can make that intuition quite quickly, whereas this type of neural network, it can't make that deduction. It only learns through exhaustive Monte Carlo simulations, which is really pointless. And also these red and blue ones here, they have such a small, feels like right now they're having such a small impact in the game. So like if I move the red one across to the left, strategically the board hasn't changed that much, so it seems kind of wasteful in terms of time and effort for the Monte Carlo simulator AI to play so many types of games when surely there's a better way to approach the problem. So yeah, I just think it was just stupid how neural networks are based on human neurons in the brain, but humans approach these games with different logic. So yeah, I just thought it was not in the spirit of an artificial neural network. A human player can play strong strategies after 1 or 2 games, or even before having just been told the rules, whereas neural networks need thousands of games to play even somewhat well, i.e. not throw the game in the first few moves. So other types of artificial intelligence design, there's a heuristic approach. So what is a heuristic? A heuristic is a collection of evaluations or algorithms which combine to give a move suggestion. So a quote from Google: "It's not guaranteed to be optimal, perfect, or rational, but instead sufficient for reaching an immediate goal." And computer science specific, a technique designed for solving a problem more quickly when classic methods are too slow. Examples would be, if you can complete the win condition, which is 4 in a row, you should complete 4 in a row. And if you can make 3 in a row, that's much more valuable than making 2 in a row, so we'll make 3 in a row. And if your opponent has a win condition of making 3 in a row, you should block it, for example putting the red one here. And obviously for games as simple as these, heuristics such as those should be strong enough to play a pretty strong game. However, so heuristics are more like how humans approach problems. However, they must be hard-coded into the computer program, which potentially has massive shortcomings. The main one being the strength of the move suggestion is limited to the strength of the strategy designed by the programmer or the team of programmers. Whereas, the benefits would be cheaper in terms of time/memory for evaluation, and the logic can be applied to any situation in the game, and a pretty strong, but not necessarily strongest, move will be played. So if we arranged a Connect 4 board in any given position, any legal position, our heuristic-based AI could, based on whether it makes 2 in a row, 3 in a row, 4 in a row, or blocking an opponent's 4 in a row, 3 in a row, 2 in a row, we could it could give a possible move, whereas a Monte Carlo AI would, if it hasn't seen that position before, it would pick a random move, which would obviously be pretty bad, especially if your opponent has 4 in a row on the next move. So benefits and takeaways to both. So the benefits of Monte Carlo techniques: the AI is free to explore all possible strategies in existence. If given enough time and memory, the AI should find the strongest move, or it will find the strongest move, especially in a game such as this, a perfect information game. The downsides for Monte Carlo techniques would be the huge amounts of time needed for complex games. Simplifications can be made, but these will introduce even more shortcomings. So this kind of applies to, say, a more complicated game like poker. You can limit bet sizing in some manner, but that will change recommended strategy basically. By limiting the options the players have, they will start playing differently than how they would in sort of an unlimited game. Either technique should be fine for games like Tic-Tac-Toe or Connect 4, especially if you did the Monte Carlo search tree during the game. So if you're only like 10 moves away from filling the entire grid, a Monte Carlo search tree would take not that long, like we're talking seconds, to figure out the best the best move. But at the start of the game, when the board is empty, as I said, there's 3.5 trillion possible game states you can play, so that would take forever. But it would, not forever, but it would take a long time. So it's more complicated at the start of the game as opposed to at the end of the game. It's pretty simple. Okay, and then with chess, so what we have with chess right now is that I think it's solved when each player has like less than 7 pieces or something. And chess is often seen as like the bastion of computers / AI versus humans. And the strongest program for a long time was Stockfish, which is a heuristic-based AI. It's developed by computer scientists and chess grandmasters. It's only recently that a neural network has overtaken it in terms of power. So AlphaZero, which is developed by DeepMind, which is owned by Google, just smashed Stockfish pretty convincingly. I think they played 1,000 games. I think they drew like 800, roughly 800, and then Google won, I don't know, like 100 and, actually I don't think Stockfish won, so maybe Google won like 100 or something, and then Stockfish didn't win any, whereas when they did something called like Opening Book, which gives Stockfish perfect moves or something for the first 5 moves, I think it did start picking up some wins there, but basically the Google AI was significantly better, basically. So yes, Stockfish was the pinnacle chess program for a long time, smashing human and other AI competition by a big margin. But yeah, one thing that came to the surface, so Stockfish obviously mainly depends on its Monte Carlo tree search, and so does the neural network, AlphaZero. AlphaZero did have evaluations available at static positions with no sort of future searching, but it plays at like a 1,500 ELO rating, it was decided, which is kind of the level I play at, like 1,600, which is basically an amateur level. Whereas when it's allowed its full search, it plays at like 3,400, and then like a top grandmaster plays at like 3,000 online, and Stockfish is like 3,200 roughly. So ballparking, it would be like AlphaZero is like 3,400, Stockfish 3,200, top grandmaster 3,000, then like an amateur like me is like 1,600. Yeah. So basically the key takeaways from Monte Carlo tree search methods versus heuristic methods for perfect information like Tic-Tac-Toe, Connect Four, chess, is that most of the power comes from the Monte Carlo tree search method. It doesn't come from, like, you can't just look at a position like this and be like, oh yeah, white's gonna win, or black's gonna win, or you should do, like, from a human perspective, we could say something like, I mean, I'm so bad at chess, but like, the knight going here makes perfect logical sense to me because it can't be kicked. It's called an outpost. It can't be kicked by a pawn or a low value piece. And then yeah, defending my pawn here or trying to defend it sort of makes sense, even though there's 3 attackers. Maybe I should just give it up, but you know, if I was given an extra move, I would want my bishop here and my rook here. Yeah. So yeah, most of the power comes from the Monte Carlo tree search. Instinctive evaluation, no search, plays at an amateur level. Heuristic approach for Stockfish with a pretty deep Monte Carlo evaluation plays pretty damn strong. So Stockfish goes like 24 moves deep pretty quickly, based on stuff like material advantage, which is who has more pieces. These are worth like 3 each. Rooks are worth 5 each. Queens are worth like something like 9. So that's like material. Whose king is safer, and who's more active. So it uses heuristics like that. So yeah, it's kind of interesting that the strongest AI for a long time was purely heuristic based, in combination with the Monte Carlo tree search. Whereas Google's neural network is it just does Monte Carlo tree search, and then it stops looking down trees which are like clearly terrible for one player, yeah, to save time. So moving on to different types of AI and machine learning, I've also looked at sentiment analysis in the form of natural language processing with IMDB reviews. That's like the hello world of natural language processing, weather prediction in terms of time series, image recognition in terms of digit recognition, and also clothing recognition. So it kind of looks like Primark's catalog of clothing. So I call these like imperfect information in the sense that the model doesn't learn the English language through and through for the natural language processing, for the weather prediction, it doesn't learn, it doesn't take lessons of geography or climate. It just takes inputs that we give it and tries to find patterns within that data. And same with the image recognition. It just looks at the sort of the intensity of the colors, and it just kind of learns which pixels are lit up and which ones are turned off, essentially. And then it learns from those from that experience. So yeah. So for example, I'll just show my notes on the screen now. So for the IMDB review AI or machine learning software package, I don't even know what to call it. So it looks at a review, or it's learnt from 25,000 reviews, 12,500 were positive, 12,500 were negative. And then you can give it any brand new review that's never seen before, and it will do an analysis, and it will try and indicate to you whether it's positive or negative. That's kind of the goal of the IMDB one. And how it does this is it takes every word that it sees, which is positive and negative, and takes each word and assigns like a weighting to it. So here we have the top 5 most positive words, and here we have the 5 most negative words. So you will see that these are really hard to use in a negative setting. I mean, obviously that excellent, perfect, great, amazing, superb are all very positive words. But it's important to note that for reviews which are like more neutral, sometimes people say, yeah, it's not bad, it's not great. I mean, great is on the list, but not great is like the only one that can go with a negative to mean the opposite. People don't really say it's not boring, not poorly, not awful. I mean, not awful, yeah, again, a bit, but it's very rare. It's not the worst. Like, you have to get, these are really niche sort of ways of writing English language. Most of the time you just say, this is the worst movie I've ever seen. Waste of time. You would never say a great movie is, it's not a waste of time, that's a very neutral review at best. And then obviously words such as like the and are just like, they'd be completely neutral. They'd have a weighting of like 0, because those words will be common in positive reviews and negative reviews. So yeah, basically builds a database of, is the word positive or negative? Then it looks at a new review, counts up the scores of all the words used, and then it makes a prediction based on that information. So yeah, the best models get about 95% accuracy. That's for like published level papers. And yeah, the ones which are mislabeled tend to be a bit sarcastic or confusing. Even when I'm reading it, like when they say, yeah, it's not bad, or it's so bad it's good, or if they're just like being really sarcastic. Yeah. So essentially what these models are doing in terms of the IMDB one is pattern recognition, same with the digit recognition. So what is the digit recognition one doing? So it studies like all of the ways. So this one's a bit annoying. So it was in my plans to do an example in Paint. So the digits number 1, they're all drawn in the same style, but in the data set that I was using, they could be drawn in like 2 different styles. So let's just say that okay, so we'll do this. Okay, so you can either draw a 1 like just a straight line, and you can also draw a 1 like, for example, like this. Okay, and then where they overlap, you could say, for example, that because the straight line down is always going to be lit up, And then the sort of the accents are like sometimes lit up. They're like optional. So if you imagine the black is a 1 in terms of intensity, grey is like 0.5 if it's half the time used or some arbitrary fraction, and then the white is like a weighting of 0 or -1. So it's kind of tricky because every number should have white space around the sides, but if you just imagine like the box here as being the most important areas of drawing the number, then it should make sense. Whereas like a number 8 would just have like a pretty dark just squiggles everywhere like this, because every 8 should look roughly the same. They might be a bit slanted, but yeah. So yeah, and then what it does is anytime it's given a new digit, so for example for 8 it would expect white space in these circles here, white space around the edges, and then sort of darkness in this looping infinity symbol. I don't know why I'm trying to describe a number 8 shape in ways that without calling it a number 8, but yeah. So yeah, depending on which pixels are lit up and which ones are vacant, it makes a prediction based on that. And it's, I think with my one and with other people's one, you can get like a model which is like 98% accurate. And it mainly uses like, so if this is the same data set, yeah, it looks like it is. They're 28 by 28 pixels in shape. So yeah, that's pretty cool, and I've got another video on that, I think, so could be worth checking out if you're interested. So yeah, the color intensity of the pixels get weighting, and also if the neural network is deep, it can start doing combination analysis. So if like certain pixels are lit up in combination, that gives it a higher weighting that it's a certain number. So for example, number 2, if there's quite frequently like a collection of darkness in like a circle or a blob in like the bottom left corner, that could be indicative of the number 2, for example. So yeah. And then for example, another one in terms of, it's called like time series, is like weather prediction. So this is just an example of weather. So here we can only see on the map that there's temperatures, but there could also be like wind speed, and also wind direction. So if we had temperature, wind speed, wind direction, time of day, like stuff like that, you could say what's the prediction going to be like in a week's time from now. But obviously there's some variables which will impact the weather, which are outside of the remit of the inputs. For example, like solar flares on the sun, for example. So just something which is completely random, which you would never include. And also like atmospheric pressure in certain places. I think atmospheric pressure is the biggest indicator for like when it's going to rain and stuff. But yeah, I'm not really sure. So yeah, and just thought I'd mention that you can have inputs which are neutral, as in they have no positive or negative correlation. Yeah, similar to the IMDB dataset where the and tokens were valueless, basically. Yeah. So these pattern recognition machine learning techniques are really different from the perfect information Monte Carlo techniques we mentioned before, where those ones were exhaustive as much as possible, whereas the pattern recognition ones are really dependent on the training data given to them, but they can give a recommendation of any new image or data based on what it's previously seen. Yeah, whereas in the perfect information games, an immediate output with no Monte Carlo searching essentially sucks. So yeah. So basically, this kind of is pushing to the limits of my knowledge of machine learning and artificial intelligence, but I was basically wondering if it's possible to build a machine learning model or artificial intelligence which can make strong predictions in a perfect information game like chess based on pattern recognition of placement of pieces, or for example hole cards and the line taken in a game like poker. So obviously poker is something I have a lot of experience in, and yeah, I've also made an AI in poker using a heuristic based approach, because I basically believe that this sort of pattern recognition approach is more in the spirit of how humans approach the game. Yeah. So yeah, we shouldn't need to search all possible combinations available. Just try to complete partial objectives along the way. So like I might have mentioned before, like if we just move this red chip one to the left, strategically the next best move for the red player is still in this column here, right? To make 4 in a row. So even though we've completely, I say completely, to the computer, moving the red chip from here to here is a completely new game space, but for a human or for us, it's like strategically the same, what we do on this position. Obviously if I didn't have 3 in a row already, the strategy would be different, but essentially what computers do is they imagine they need to look at every possible outcome to have a good knowledge of what's going on, which I don't think is necessary. That's essentially what I'm trying to make, the point I'm trying to make. So yeah, my experience with making a heuristic AI for poker, it's super fast. It can make an evaluation or suggestion to play within like 0.3 seconds, compared to the strongest sort of like AIs for poker take about like 3 minutes in certain situations, but they do sort of a pseudo sort of perfect information Monte Carlo tree search, where they pretend both players can have any combination of hole cards, and then they play any possible strategies for all players, and try to adjust the strategies to maximize effective value for all players, which is obviously very thorough and is going to give stronger suggestions than my heuristic based AI, but yeah, it's much slower. And obviously these are people working at universities and stuff, basically doing PhDs. Whereas like my heuristic based one, it just needs the board texture and hole cards. And some cons of the heuristic one, it doesn't take into account the line taken for the players. Who was the last aggressor, who's defending. So yeah, human knowledge is needed to do a very simple analysis of like what action do we take, depending on if you're the aggressor or defender. So basically, why is this significant? Well, poker is the most real life like game than all of the other forms that I've mentioned. Players will be strong and weak at different times, hiding their strengths and weaknesses, i.e. deception, bluffing, trying to induce mistakes, punish mistakes, and yeah, anything else. So, I'm talking about like country states now, like, military. The implications are quite massive. Like, for example, I think the head developer of Carnegie Mellon, which I think is like a university in America, he developed sort of the first really strong poker AI, and then he got like a $10 million grant or something. It was millions of dollars to work for the Ministry of Defense in America. So yeah, they obviously think it's kind of important. Allocation of resources, stuff like that. So where you put your strong assets, that applies in poker and also in real life. So yeah, I'm just trying to be clear that like we don't need to look at exhaustively at every situation. We don't need, in poker, chess, whatever, small deviations can be removed and the spot is strategically the same. And then yeah, I thought I would also mention some sorts of machine learning, which I think are like garbage basically, or not impressive. Stock price predictor based on previous price. I think the best sort of studies, or the most thorough studies, have indicated that there's no correlation between past price and previous price. Basically, technical analysis is astrology or tea leaves. Sports predictor based on historical match data. This is a bit iffy. So a game like football, where it's not taking into account shots on target, shots taken, corners, throw-ins, I don't know, yellow cards, red cards, there can be quite a large deviation from the final scoreline and the performance of the teams. So that's why I've said that. Whereas in a game like tennis, so that was football as in soccer, whereas in a game like tennis, the outcome has a really high correlation to the skill of the players. So that a tennis model would be much better suited to a neural network machine learning project. So yeah, that's kind of everything I wanted to talk about. This video is a bit longer than I first expected, but if you have any thoughts about AI, machine learning, all the things I've mentioned today, I would love to hear about them and maybe discuss them with you. So yeah, I hope you found it interesting. I hope